Model building in multiple regression. When we build a regression model, there are many things that we need to consider, and one of them is the selection of the independent variables that need to be included in the model. Here are three general guidelines for selecting independent variables. First, you may want to include the relevant variables to make them most useful for theoretical purposes. This will enable a researcher to address hypotheses posed by the study with sensible control and mediating variables. Second, include enough variables to obtain good predictive power. You may want to develop a regression model that accounts for most of the variation of the dependent variable. That is, develop models that maximize the explained proportion of variation in the dependent variable. And third, the regression model should be as parsimonious as possible. That is, as simple and economical as possible. A number of times we may elect to run simultaneous or standard regression analysis, where we include all of the variables in the analysis at one step. Again, this is called simultaneous, standard, or direct regression analysis. Statistical software has automated variable selection procedures that scan the independent variables to construct a model. These routines or search procedures sequentially enter or remove variables one at a time according to some criterion. Essentially, these search procedures are processes where more than one multiple regression model is developed for a given dataset, and the models are compared and sorted by different criteria depending on the given procedure. The most popular automated variable selection methods are hierarchical regression, stepwise regression, forward selection, and backward elimination. In hierarchical regression, predictors are selected based on previous experience or past work, such as existing literature or theoretical models that have been used in previous studies. Therefore, the researcher decides in which order to enter the predictors into the model. As a general rule, known predictors should be entered into the model first in order of their importance in predicting the outcome variable. Then the researcher may enter other predictors either all in one step or in a stepwise manner, or what we call hierarchically. Stepwise regression is a step-by-step process that begins by developing a regression model with a single predictor variable and adds and deletes predictors one step at a time, examining the fit of the model at each step until no more significant predictors remain outside the model. For example, in step 1, the k, or the number of independent variables, are examined one at a time by developing a simple regression model. The model containing the largest absolute value of t for an independent variable is selected. If, after examining all possible single predictor models, it is concluded that none of the independent variables produces a t-value that is significant at a specific value of alpha, the search procedure stops at step 1 and recommends no model. In step 2, it examines all possible two-predictor regression models with x1 as one of the independent variables and determines which of the other independent variables in conjunction with x1 produces the highest absolute t-value in the model. At this point, the process pauses and examines the t-value of the regression coefficient for x1. Sometimes x1 may become non-significant when x2 enters the model. In that case, stepwise regression will drop x1 out of the model and go back and examine which of the other independent variables, if any, produces the largest significant absolute t-value when that variable is included in the model along with x2. Note that the coefficients are likely to change from step to step to account for the new predictor being added in the process. In step 3, it begins with independent variables x1 and x2 in the model. At this step, a search is made to determine which of the remaining independent variables in conjunction with x1 and x2 produces the largest significant absolute t-value. If no significant t-values are acknowledged at this step, the process stops here and the model determined in step 2 is the final model. In a manner similar to step 2, the process goes back and examines the t-values of x1 and x2. If either or both of the t-values are non-significant, the variables are dropped out of the model and the process calls for a search through the remaining independent variables. Forward selection is essentially the same as stepwise regression, but once a variable is entered into the process, it is never dropped out. It begins by finding the independent variable that will produce the largest absolute value of t in predicting y. The selected variable is denoted as x1. In step 2, while retaining x1, it examines the other independent variables and determines which variable in the model with x1 produces the highest absolute value of t that is significant. To this point, forward selection is the same as stepwise regression. At this point, forward selection does not re-examine the value of x1. Both x1 and x2 remain in the model as the other variables are examined and included. The backward elimination search procedure is a step-by-step process that begins with a full model, that is, all independent predictor variables. Using the t-values, a search procedure is made to determine whether any non-significant independent variables are in the model. If no significant predictors are found, the backward process ends with a full model. If non-significant predictors are found, the predictor with the smallest absolute value of t is eliminated and a new model is developed with independent significant variables. Stata allows you to choose any of these methods. According to some researchers, the stepwise methods, such as forward and backward, take many methodological decisions out of the hands of the researcher. There is also a danger of overfitting, that is, having too many variables in the model that make little contribution to predicting the outcome, or underfitting, that is, leaving out important predictors. For these reasons, stepwise regression is often avoided unless the purpose of the study is exploratory model building. When there is sound theoretical literature available, then base your model upon what past research tells you about a specific topic. Let's take a look at exploratory versus explanatory research. Explanatory research has a theoretical model to test using multiple regression. It is based on previous research that has been conducted on a particular topic and has developed a model that includes multiple relationships among variables and how these variables may interact in predicting the outcome variable. Exploratory research, on the other hand, seeks to uncover a good set of explanatory variables, that is, independent variables, that are associated with the outcome, and does not really examine theoretically specified relationships. This document here on the right specifies the commands that can be used in Stata to build a regression model using the stepwise command and several others. The following is an example taken from Stata using the automobile dataset. In this example, stepwise regression is chosen. Notice that the variable was dropped from the model if the p-value was larger than 0.2. This p-value is specified in the command line as PR parenthesis 0.2, and it is part of the first command line where stepwise is entered first, such that stepwise, comma, probability of 0.2 or less, colon, regress for regression, MPG is the dependent variable, followed by the independent variables of weight, weight 2, DISPL, gear, turn, headroom, foreign, and price. As you can see, once this model is run, several variables were dropped out of the model because they did not meet the criterion or the cutoff of the p-value of 0.2. So in this example, the final selected model includes the variables of weight, weight 2, foreign, gear, and turn. All, as you can see here, the overall model fit is statistically significant, and several of the variables that were chosen to be part of this model are significant predictors of MPG, which stands for miles per gallon.